Okay, so we did not get through the entire in-class lab due to some technical errors and also just having a lot of material to cover that really could not have been done within 50 minutes. So today I'm going to walk through the entire lab. We're going to take it really slow. We're going to do it exclusively on EC2 so that there are no issues with, it doesn't run on Mac or doesn't run on Windows or terminal problems. We're going to all do it on the same platform. We're going to start by kind of re-going through what we covered in class. And then I will also cover the rest of the lab. And if you complete that part and do those screenshots, then you will receive 10 points extra credit on your lab grade. So to start, I'm going to walk us through how we can actually go ahead and start launching containers on EC2. So we're going to configure our server basically to have Docker installed, configure the CLI, etc., everything we need to get this up and running. So let's go ahead and start there. So first, again, log into the AWS console, and then we're going to go to EC2. So hopefully none of us have any instances running unless you're doing some sort of personal project. We're going to go to instances, and then we're going to launch an instance. So again, we're going to use this Linux 2 AMI. And again, an AMI is a template for an instance. So I could have a Linux 2 template that creates a Linux 2 instance or a Linux 2 server. I could have a Mac template that creates a Mac server. I could have a Red Hat template that creates a Red Hat server. And in the same way, we are going to be making Docker files, which will help package our application, whatever we're trying to run, into an image. And from there, we can have our image of our application actually create a container that runs it. So again, we will have our code packaged up using a Dockerfile into a AMI, so to speak, for containers. It's called an image, and that image will then be used to make containers. In this case, again, we're still working with EC2 to get our platform set up. So we're going to select this. And then it's going to, again, stick with the defaults, T2 micro. We don't need to worry about any of our subnets. Make sure you have your auto IP enabled if you've, edited the Northern Virginia region at all. One thing to note, we are going to use the Northern Virginia region. That is US-East-1. So we're going to stay there. And then we need to use the bash script that I provided in for our user data. So that script is already on Elm. So I'm just going to pull it up from my personal computer. So what this does is it checks for updates, installs Docker, starts Docker, installs Git, downloads and installs the version 2 of the AWS command line. Then we install Docker Compose. So that is for multi-container architecture. And then we are going to, finish up that installation. And then we are going to ensure that anytime we want to run these Docker commands, we don't need to preference it with sudo. We can just run it directly. We're going to start the Docker service again after running these installations a second time, and then ensure that it stays on even if we reboot. So we're going to copy this script, make sure it has that bin bash part at the top. We're going to paste it into our user data, keep our storage as default. Let's give our instance a name. I'm going to call it 299B containers. And our security groups. In this case, I already have an existing security group that has everything I need. I called it Docker. And I have HTTP open to port 80. I have SSH open on port 22. I have 443 open. That is HTTPS. And I have a custom rule open to port 3000. You would have needed this port open had you been running one of the original Docker images that we skipped kind of for class time, but we're going to have this port open as well. So again, you need ports 80, 22, 3000, and 443, and these should be open to anywhere when you are creating your security group. Then we are going to review and launch. So just to recap, T2 Micro running Linux 2, your Docker security group that has those 4 ports open, and then again, make sure you have already pasted in that user data. We are now going to launch, and it's going to again prompt, hey, do you have that key pair? Yes, I do. and launch instance. If you don't have the key pair that it's selecting by default, again, make sure you create a new key pair. So it's going to launch our instance. And this is going to take a little bit of time because it's, installing Git and Docker and the CLI and getting all of that set up. So I'm going to take this time now to do a brief overview of what we're going to cover in this lab. So the high level is we are going to start by creating a multi-container architecture. Now, the reason we're starting with the multi-container architecture is because it takes a long time to create all of those resources. It's significantly faster than if we were to do it ourselves, but it still does take about 10 to 15 minutes for that command to run. So what is the architecture that we're creating? I'm going to paste all of these links in the chat so that when you access this recording, you'll have it there. So we're going to start by going to this first demo. And this is a demo by Massimo Ferri on creating a multi-container architecture. So let's take a step back and talk about what that means and why it's important. If I wanted to build a complex application, so maybe I have a database with a web application and I've got a cache and maybe I have another component as well. Building all of that from scratch in AWS is pretty time consuming. I mean, it took us about half an hour to 45 minutes just to install WordPress on one EC2 server and one RDS instance. So the advantage of using Docker Compose is that we have 4 images already for our container, and we can launch each of those images as a separate container in AWS. And Docker Compose uses a specific file format called YAML that will translate from basically Docker language or Docker syntax to AWS syntax. And that's the advantage of using something like Docker Compose, is we can quickly go from running something on our local machines to deploying in the cloud with very little effort. So what does it look like? And I'd encourage, if you're interested, read through some of this overview. But in general, we have our browser. So that's going to be us, opening up Chrome or Edge or something. We will go to our load balancers endpoint, and it will point us on port 80 to this UI. So the UI stands for user interface. That's what you see when you interact with a website. Then we have a second container, and that runs our app server. So that's a lot of the behind the scenes that our UI doesn't show us, but it's kind of like the meat or the logic of the app. Then we have another container. This is our database. So that is for persistent storage. In this case, it's running Postgres. We've worked with MySQL. And we have a fourth container, and that's going to be Redis. This is our cache layer. And cache, again, is super fast memory that allows us to quickly retrieve information that is frequently accessed. So to recap, we have our browser, so that's us, connecting using a load balancer to our UI. UI, again, is the user interface. That's what we see. That UI relies or depends on our app running, which relies on our database and our cache being available. So there's a hierarchy as well. So we all have already run this git clone command. I'm going to run it again, just because it's not on our Docker or our EC2 instance yet. And we'll walk through the rest of this. So let's check in on our EC2 instance. So it looks like it's still in this initializing state. So we'll give it a few more minutes before we try to connect in. So once we clone the files, and again, git clone is a way of copying code from somebody's repository. So let's say I wrote code that allowed me to have a Python app that showed me where all the buses are on UMD's campus. I could push that code to a service called a GitHub. And then if anybody wanted to try to replicate that app, they could use my code, copy it using this clone command, make any modifications or improvements, and then run it themselves. So we're going to copy Massimo Ferri's files for this Yelb app. We are then going to change our directory using cd into a specific folder that has 3 files. We have a README, that's just a guide to the code. We have a Docker Compose file, and we have a stack deploy. And Docker Compose, this is the file that's going to be of the most interest to us. This is a template for the containers that are needed to run Yelp. Again, kind of looking at the business side. If you are trying to develop a complex application for your customers, it's much easier to box it into small pieces called containers and have the ability to quickly spin up new containers rather than to have to manually build this on a server every single time. So there's a lot of benefits in terms of agility, but also we'll look at how we can have elasticity and high availability also built in. So let's check in again on our EC2 instance. Let's see if it's in a running state. So it's passed our 2 status checks, and now we can connect. So I'm going to hit connect, and I'm going to use EC2 Instance Connect. I am in Chrome, so I'd strongly recommend that if you're going to go through this lab, you also complete it in Chrome. I'm going to connect in. So now I have a terminal available to me. So the first thing I need to do is start running through some of those prerequisite commands. So if we go back to Canvas and we look at our assignments, we can look at that prerequisite submission and complete some of those commands. So first things first, we want to check if the version of our command line is correct. We need version 2. There was a version 1 that AWS created, but it has some problems with the Docker integration. So we're going to run this command, and we're going to confirm that we have version 2 correctly installed. Again, if you've already gone through this step, feel free just to fast forward until we actually get into some of the Docker commands, but I'm just going to show all of it from scratch. Then we're going to run this AWS configure command. This command will allow us to authenticate from our local machine to the AWS console. Why is this important? Well, we don't want just anybody able to start suddenly launching resources on our personal AWS accounts. That can be costly, dangerous, come with a lot of security risks. So we want only people that we've given those access keys in IAM the ability to use our AWS account and launch resources. So I'm going to run this command. It's going to prompt me for my access key and secret. Here is where I'm actually going to stop sharing. I'm going to keep recording so that I'm not just giving away my secrets. Again, these are providing admin access to your account, so you don't want to give these keys out to just anyone. So I'm going to privately open up a tab to go to my console. I'm going to go to IAM. I'm going to find the user that I have created for this. That user must have admin access, or at least for the purposes of our lab, it's easiest to give them admin access. I will go to the Security Credentials tab, and that is where I will create a new access key. So I'm going to make my old one inactive. I'm going to then delete it. And then once I have deleted it, I'm going to create a new one. So I'm going to hit Create Access Key, and it will show me the access key and the secret. I would strongly recommend you also download the CSV file at this time so that you can refer back to those credentials later if you need them. So I'm going to copy in my access key ID, paste it in. Then I'm going to copy in my secret access key. I'm going to paste that in. I'm going to type in US-East-1 for my default region. I want to launch resources into Northern Virginia. And I'm going to specify my output format as JSON. That is JavaScript Object Notation. It's just an easy way to make sure everything is standardized when we have output. I'm now going to clear my screen and resume recording so that we can follow along from there. So let's go ahead and keep going. Again, all I did was create a new access key for my IAM user who had admin access abilities. I typed those in using the AWS configure command, specified US-East-1 as our default region, and JSON as our default output format. Okay, now let's keep going. Let's use this AWS S3 ls command to check that our configure worked properly. In this case, I'm able to see all of the buckets in my personal account. So I'm now able to authenticate from whatever my local machine is. I could be an AWS server, it could be my own personal computer, it could be somebody else's computer, and I'm able to talk to or get information from my personal account. Next, let's check if Docker was properly installed. So we're going to run this docker -- version command, and we can see we have Docker version 19 installed. Then we're going to check if we can run our getting started container. So it says the image is not already existing on this machine. So I'm going to pull it from Docker. In the same way that we can push images, we can also pull them. So if somebody writes a really cool application on Python and creates a Python image, I can then say, I want to run that really cool application as a container. So I pull the image and then I run it as a container. So this command says I want to use Docker to run a container in detached mode. So I don't want a terminal inside of the container. I just want my terminal returned back to me. And I want to open up port 80 on my host machine, so this EC2 server, to port 80 on my container. And I want to use the Docker getting started image. So if that works, we can test it by going to our public IP, pasting it into our browser, and we should see that our container is now up and running. So we've done all of that well. What's next? Now we need to clone this Yelp repository. Again, many of you should have already done this on your local machines or on an EC2 instance. If you've done it on your local machine, I hope you're following along on the EC2 instance. If you've done it on the instance, there's no need to go through these steps again, just follow along after this step. So now we're going to clone the repository. And just to see what that repository looks like, let's go ahead and take a look at it. It's going to take us to a service called GitHub. And we can see that this is the information, or these are the files that he's uploaded. So we've got stuff around the app server, the database, the UI, some images. It's got a README. A README is a standardized way of telling people that this is the file they should read to get information about the application. And he's got some diagrams explaining what's going on. A lot of this is the same stuff that was on the tutorial website. This is our end goal. We want to run the Docker Compose command to be able to have access to this full UI dashboard. So now that we have an understanding of what we are trying to do, let's go and actually do it. So we are done with the prerequisites. No need to worry about that now. So we're going to keep following along with his tutorial. So we've cloned the repository. Now we need to use the change directory command to actually get to this Docker Compose file. So now we are going to go into our instance, and we can type ls to see the contents. And we do indeed have this Docker Compose YAML, a README, and a stack deploy. So looking at our instructions here, we want to use that Docker Compose file and deploy on AWS. So how can we do that? First, let's create a context. So a context is what tells Docker if we are creating containers on our local machines, so our personal computers or servers, or if we are creating containers elsewhere. In this case, we want to create containers on ECS. Again, tying it back to overarching business goals. What we're doing is making it very easy to move from a local deployment or a local testing environment into production very rapidly on AWS. So once you have run all of your containers in your local environment and check that everything works and you're ready to ship this out to your customers, or maybe it's an internal service for your own employees, we're now going to make it very easy to go from it's just running on one person's machine to running on AWS resources. So let's see what this looks like. First, let's take a look at our Docker Compose file using cat. And cat is a short for concatenate. It allows us to inspect the contents of a file. So what do we have? First, we have a comment that's just saying, use this with the Docker Compose command. It's running on version 3. And we have 4 services. So we have our Yelp service, or our UI. That is, again, what we will be interacting with. That's the website front end. We have the app server. That's kind of the meat of the logic. We have a Redis server for caching, and we have a database. We also have a network. This network is basically a way for our containers to talk to each other. So looking back at something like the WordPress lab, we had to set up security groups to allow our EC2 web server to talk to our database. Similarly, we need to have a way for our app server container to talk to our UI, or for our database to talk to our app server. And that's what's just called a bridge. Again, this is all very kind of standard Docker syntax, and this will be done automatically for us in AWS. So just to recap, we have 4 services. We have our UI, our app server, we have our Redis server for caching, and we have our database, and then we have the network that allows each of these containers to talk to each other. One other thing to note is this depends on trait or key. So what this is saying is that our user interface depends on our app server running. No point in having a website up if there's nothing that the website will be able to do. Similarly, we can't run our application if we don't have our database and our Redis cache up. So it creates a hierarchy. It's ensuring that these containers, our app server and our UI, will only be running if our Redis server and our database are also running. So now that we have a good understanding of the purpose of this Docker Compose file, how do we translate this from just words on a screen to actually running AWS resources? Now, the way for us to do that is to use what's called a Docker context. A Docker context, again, just specifies if we are trying to run on our local machine, so our EC2 instance, or if we want to run containers on AWS. In this case, we absolutely want to deploy to the cloud. So I'm going to use Docker context create, and then I'm going to say ECS. I need to specify that I'm using the Elastic Container Service and call it my ECS context. It's going to prompt me if I want to use an existing AWS profile, secret or token, or environment. I want to use an existing profile, so I'm going to hit enter, and it's going to say, do you want to use your default? Well, that's the only profile on there. So I'm going to hit enter again, and it's going to say that I successfully created my context. Now, just to make it easy, I will go ahead and paste that command in the chat, Docker context create ECS, my ECS context, to make it easier to follow along. All of the other change directory commands, etc., those are either from the tutorial or from the Elms prerequisite assignment. Okay, we now have a context that allows us to deploy to the cloud, but we have to actually use it. So this is something you don't need to run, but just to see, we're currently using our default context. And it says, hey, you're running on your Docker host. And that's really all we need to know. So we don't want to use our default because that will deploy our resources on our actual server. We want to deploy on AWS, so we need to switch to that context. So I'm going to say Docker context use my ECS context. And it will again just output my ECS context as confirmation that you have switched. And again, I will type this command in the chat. So Docker context use my ECS context. All right. So let's keep going. Now that we have our ECS context and we understand what we are trying to run, again, we want to run 4 containers, a UI, an app server, a Redis server, and a database. Let's actually put that on the cloud. To do that, we just need one very simple command, Docker Compose up. Don't worry about this warning. This is standard expected output. It's basically saying, hey, I can't create like this network container thing in the cloud. I'm just going to use security groups instead. But the nice thing is it automatically translates from this network bridge system that Docker usually uses from local deployments, and it will create the security groups for us. And it's going to start creating a lot of stuff. It's going to create task execution roles. So that defines what our containers are running and how many containers we need. It's going to define our load balancer. So how do we actually connect to our containers? How do we ensure that it's highly available? And it's going to create stuff for our app server, our Redis server, the UI, and the database. This will take a lot of time to run, which is why we've done it first. Let's go ahead and inspect our instructions to see what kind of screenshots we may need to make. So right now, still no screenshots just yet. We're going to pivot to creating our own Docker file and pushing our own image to the Elastic Container Registry. So how do we do that? We're going to go to this link. I'm going to paste it in the chat. And we're going to follow along. So first off, what are we going to be creating? It's going to be a very simple JavaScript application. JavaScript is just a way for websites to be interactive and reactive. So if you push a button, does it do something? How do we make websites a little bit more fun? So we are creating a simple app. It's just a kind of to-do list. So we don't need to worry about the contents. And again, this is where the business side comes in very, very handy. I don't need to be concerned about the contents of the application. I just need to know, how do I get it on the cloud? So to do that, I create what's called a Dockerfile. And the Dockerfile is a set of instructions for how to turn, my bit of code into a container image. And again, an image is just a template to create containers, kind of like an AMI is a template to create an instance. I'm going to say I need to use this Node.js image. I need to use APK, which is just a way of downloading packages. So I need a Python package. I'm going to set the working directory of my container to this /app folder. I'm going to copy all the files to the app folder. I'm going to do an installation, and then I'm actually going to start it using this Node.js command. If for those not as familiar with JavaScript, a similar example would be deploying a Flask application with Python. So let's say we just wanted a web app on Python that says, hello, Docker. So that's basically our code. And maybe it's got, Flask installed as well. To make a Docker file out of that, we would say, hey, I want to use the Python layer. I'm going to switch to my app working directory. I'm going to copy this requirements.txt file that tells my application which Python packages I need to actually run my app. I'm going to use pip to install those packages. So in this case, it's just Flask, but maybe it's pandas, maybe it's Beautiful Soup if you're doing some kind of web scraping or HTML parsing, anything really that could be a Python package. I'm going to copy those files and I'm going to run my Python app. So again, it's just a simple set of instructions for how do I turn app, code running on my machine into a image template that other people can then use to make containers. If you're curious about referencing this, for those more interested in Python, I will paste this link in the chat as well. So where do we go from here? Just to recap, we are still creating all of the resources needed to launch our multiple container architecture on AWS. So we're again just going to let this run in the background, and we're going to go back to this connect window and open up a new terminal. So we have one terminal that's just going to run, and we have another terminal that is now returned to us. So what is next? Well, let's go ahead and clone another repository. So I'm going to put this command in the chat. And this will again allow us to copy some code. So let's take a look at what that code is. It's just the code needed for the getting started Docker tutorial. So it's going to launch our kind of to-do list bulletin board app. So this is just the code that we need to actually make that app ourselves. So let's go ahead and run that git clone command. So if we go back to our instance, let's type ls to see our contents. Right now, we just have Yelp. So let's go ahead and copy the Docker getting started repository. It's just going to copy those files. We can type ls to confirm. And now we have two folders, one for Yelp. This is our Docker Compose multiple container architecture. And we have this getting started Docker repository. That's going to be just one container at a time. So going from there, we now want to change directory into our app, and we're going to create a Docker file that will allow us to turn this, couple of code files into a running container. And again, for the business students out there, this is where you save a lot of time, a lot of money on deployment, because you can quickly say, I have some code, I'm going to wrap it all up in a nice little box, and I'm going to turn it into a container. So I'm going to change my directory, and I'll go ahead and paste that command in the chat as well. And now if I do an ls command to list the contents, I can see that I have, my JSON, two other folders, and another file. I need to create a Docker file here that will allow me to turn this bit of code into a functioning template and image for our containers. So to do that, I'm going to type nano Dockerfile. So nano, again, is a text editor, and it will create a file called Dockerfile. Pay special attention here that it is a capital D. Don't put a .txt or anything after, just nano space Dockerfile. I'm going to paste that command in the chat here. So nano Dockerfile. Well, what do we put in there, Dockerfile? Fortunately, our tutorial tells us everything we need. So if we scroll down to where it says build the app's container image, and again, it's just a script of instructions used to create an image, we're going to copy these contents and paste them in here. So this pasted a little bit ugly. So let's try this again. Let's back out of all this. Let's try and copy those contents one more time. Sometimes it does help if you omit a leading space and just start with that capital F. So let's try this again. Copy. And let's go back to our instance and paste. So it still seems to be a little bit ugly. So we will just manually put in those those new lines as needed. So this is getting a little bit strange here. I'm going to go ahead and exit this file. I'm not going to save. We're going to try this again. So let's type ls. We can see it did not save our new Docker file. So let's try nano Dockerfile. And in this case, I'm going to actually copy the contents and format it myself first. So I'm going to copy this. I'm going to open up Notepad. If you're on a Mac or some other device, just open up whatever your text editor is. I'm going to paste this in. I'm going to remove all of these leading spaces. I believe that is what is causing the problem for our command. So let's check and make sure there are no spaces afterwards. Doesn't look like it. We're going to try and copy this one more time. And then we're going to be extra precautious. And it looks like it's still not quite running here. But we'll see if this works. So we'll go ahead and hit Control X and yes to save and hit enter. Let's try and cat the contents of our Docker file. So it looks like it's still kind of smushed, but we can see if it still works with our command. So now we are going to turn our list of instructions into a container image. So I'm going to copy this command here. I'll paste it in the chat. And what this will do is use the current directory. So this period says, hey, I want to use this, whatever Docker file is in my current directory. So this Docker file, I'm going to build an image with it. I'm going to call it getting started. So this T stands for tagging. It's a way of naming your images. I could call it, Graham Shuckman 299B lab. I could call it ASDFGHJKL, or I could call it getting started because that's the image we're trying to create. So let's see if this works with our smushed Docker file. So I'm going to say Docker build, call it getting started, and hit enter. So what error do we have here? Saying the command build is not available in our current context. Now, again, remember, we had switched to the ECS context to deploy resources on AWS. Right now, we want to build this file locally, then push it to the cloud. So we need to say Docker context use default. It'll tell us, hey, you're using the default output. And now, if we go into, I'll paste that command here, Docker context use default. Now, if we try our build command again, so let's go ahead and say Docker, Docker build -t, getting -started period. So it seems to not like our file being a little bit smushed. So that's okay. We will build it from scratch ourselves. So we're going to type nano Dockerfile, and we're going to fix this. So if we look at our terminal here, or our browser here, we need each of these commands to be on a separate line. So let's go ahead and do that. So I'm going to go ahead and hit enter. And it seems to be kind of highlighting it in a very strange way. So I'm just using my cursor now to try and see where this file is. So let's go back to our file here. So run apk add, the last line or last word is make. So I'm going to hit enter. I'm going to remove the leading space. I'm going to again put these commands on each of their own lines. So /app and then this copy command. Let's go ahead and get rid of that leading space. Hit enter. Again, let's get rid of this leading space. And then we have this run yarn install -production. Great. It somehow seems to have masked the old version of it. So I'm just kind of going back and forth with my arrow keys. Again, I'd personally recommend maybe just typing this in manually. It seems to be a little bit weird copying and pasting. So let's get rid of that last leading space. Let's get rid of this blank line. And now we seem to have our Docker file. So we can check we have no spaces. Again, I would really recommend just typing it all in manually. Seems like we have a space here. Nope, good. Again, let's hit Control X and yes to save and enter. Now we can write cat Dockerfile to look at its contents, and now it seems to be correct. So let's try our build command. I'm going to use my up arrow keys to look at previous commands written, and I'm going to say, just use this Docker build command again. And now it all seems to be working. So it's going to have a ton of output. It's pulling these different layers we need. It's packaging all of our code up into essentially a very fancy zip folder. And then it's going to turn our code into a container image so that anybody can start running it as long as they have Docker installed. So again, kind of bringing this back to the business side, this makes it very easy to do testing. So let's say you have a team that built a really cool app and your analytics team wants to be able to run it. Well, rather than have to try and send them all the files and see if they have the right libraries installed and the correct version of Python, and maybe they're on Windows and your other team's on Mac, you can package it all up as a container and send it over to your other team. And then they can start playing around with your application. Maybe they want to make some edits or changes. And it just allows for very easy code packaging and code sharing to speed up deployment. And so it'll say, hey, I successfully built this image and I gave it this name and I tagged it latest. So this is the newest version of our getting started image. So now that we have our getting started image, let's look at our next steps. So we created our Docker file. Now we're going to cat it and we're going to take a screenshot. So looks like we jumped the gun, but let's go ahead and type cat Dockerfile and be sure to take a screenshot here. So we need to see this output in your screenshots. It needs to say from node 12 Alpine and end with this command here. And again, I'll type this command in the chat one more time. You want cat Dockerfile to see the contents of the Dockerfile you created. And again, why is this important? It makes it very easy for us to package up code as a container so it can be run on any environment. It makes it very easy to test and deploy our applications. So we have done that now. We took our screenshots. Now we want to actually push this Docker file, and let's go ahead and get it on AWS. So we have our image. How do we run it on AWS resources? So we're going to follow along with this tutorial here. I'll put this link in the chat. And we'll follow these instructions to actually get our resources on AWS. So fortunately, we've already done a lot of this. We've installed the CLI, we've installed Docker, we've run a lot of these commands, we've created our own Docker image, we've tagged it, and now we are going to create our own registry. A registry is a place where we can store our own private images. So let's say you have a company and you are creating applications. You probably don't want all those applications to be public. You put in a lot of hard work to write all that code yourself. So you want that to maybe be a private registry so that only you and your team, excuse me, can run those applications. Alternatively, you can look at the public registry. So just for fun, let's go ahead and have a new tab here. And let's look at what ECR is. So very similar to EC2 when we have our selection of AMIs, we can look at this public gallery, which are different container images that people have put on ECR. So there's one for CloudWatch, there's one for Nginx, which is allowed for like HTTP servers. There's one for Linux if we want to run a Linux AMI, but essentially as a container. We have X-Ray, and that's for debugging serverless apps. We have all sorts of things. For those who did the extra credit, we even have a Neo4j image. So if we wanted to run Neo4j on AWS resources, we have a ECR image template to do that. Okay, but let's put our own image on AWS. So again, how do we do that? First, we need to log in and authenticate to ECR. So we're going to use this command with the AWS CLI. Again, hopefully all of you are following along on EC2. So we're going to use this. If for whatever reason you are on Windows, you may need to use this Windows PowerShell command. I'm going to copy this command by clicking the clipboard. And I'm going to go to my instance. So I'm going to close out of ECR here. And we are going to paste this command in. So let's go ahead and do that. And we need to make a few edits. So first is our region. Our region in this case is US-East-1. Then we need to replace our account ID. Well, where do we find that? In the top right-hand corner, if you click the drop-down next to your name, you'll see your account ID. Copy that number in its entirety. And then you are going to want to replace before this period with your own personal account ID. Again, make sure it's your full account ID, then period, DKR, etc. And last, we have one more region. So we need to replace this word with US-East-1. Make sure there is spaces before the pipe command and after this region. Now hit enter. If all goes well, it will say login succeeded. You may get a warning that it's unencrypted. That's perfectly fine. Everything we're doing, is very basic. We're not trying to actually turn this into a real company. But in reality, you'd want to put a little bit more security into your login commands. But that's okay for our purposes. So what's next? Now we need to actually create a repository. So we have logged in, and now we're going to create our own repository. Again, this is a place where we can store our private images. So we're going to copy this, and we're going to paste, and then we are going to change this from saying hello world. Whoops. So it looks like we can't up arrow key here. So I'm going to try and click. Doesn't allow us to. So we'll have to edit this command manually. That's okay. So first, let's use Control C. Control C kills a command. And I'm going to edit this command myself before copying and pasting it. So again, we can get rid of our Dockerfile template here. I'm going to change from hello-world to getting-started. So the name of my repository will be getting-started, and the name of the image inside of it will also be getting-started. We can keep this as the defaults. Scan on push will check for security vulnerabilities every time we push an image. And then again, we want to use this USD1 region for Northern Virginia. I'm going to copy this command, and I'm going to paste it back in my console. I'm going to hit enter. And again, if all goes well, we should see that we were able to authenticate. So it has given us this output telling us that it created a resource or a repository, and that it also has some default encryption. So now that we have we've logged in and we've created our repository, let's go ahead and actually push our image of the Getting Started container to AWS. So let's go back to our tutorial and let's do step 4. So we can look and see if we've created that image. So let's type Docker images, and we can see we have 3. We have the one that we just created 7 minutes ago. That's called Getting Started. And then we have the original Docker Getting Started, and that is when we first ran the container command to test that Docker was running correctly. This is the Getting Started image that we care about, because it will be the one that runs our kind of bulletin board application. So now we need to tag our image, and then we can push it. So let's go ahead and copy this command. And we are going to go into our console, and we're going to change from hello world to getting-started. Again, we need to replace our account ID. So let's go ahead and copy that. Okay. And again, we need to replace hello-world with getting-started. If all goes well, you will have no output. If there is output, that probably means there was an error. And I'm just going to check to make sure that I put this link in the chat, and I did. Yep. Okay. And then we have one more command that we need to run. And that command is to push our image. So we're going to, again, copy this command, go to our console, and paste. And just like before, we need to replace hello-world with getting-started. So the previous command basically tagged our image and said it's going to get sent to our AWS repository. The push command will actually send it all on its merry way. And again, we need to replace our account ID. So again, one last time, we're going to copy that account ID, and we're going to paste. So it's going to say, hey, I'm pushing all of the layers that make up this image. So one thing to note about images is that they're made of multiple layers. So if I have a Python image, maybe I install a library. Then I create a new image from that called, my Python image plus library. Then maybe I create an application from that Python plus library image and create a new image from that. Now I have Python plus the library plus the actual application, and that's a new image. So images are composed of layers. And the reason this is very advantageous is that layers allow us to not have to build everything from scratch. We can take something that somebody's already made and improve upon it. Just like how you don't always need to, say, build a car from scratch. Maybe you have kind of your base model, and then the dealership can give you, a nice sound system. And then maybe they can give you, like a cool muffler on top of that. So you can take something basic and you can build on top of it to get something more complex. All right, so let's go back to our instructions doc and make sure we haven't skipped anything. So our second is we want to now check that this is actually in ECR. So again, we had to push the image to ECR so that we can launch containers from that template. Just like how when we're creating an EC2 instance, we choose an AMI, and from that AMI, we create a server. So I can have my Linux 2 AMI, I could have Windows Server, I could have Mac OS, I could have Red Hat, Ubuntu, etc. Those are all templates for what we actually want to create. So let's see if this worked. We're going to go to AWS. We're going to have a new tab. And now if we look at ECR, the Elastic Container Registry, we should see that we've created a private repository. So again, this is just for our purposes. And we have an image inside of it that's the latest image of the Getting Started repo. And we can see it's 139 megabytes and it was created 2 minutes ago. So this all worked perfectly. If you get to this screen, take a screenshot here. So again, following along, take a screenshot after showing the full image details in the repository. We want to see the time it was created. We need to see your account name in the top right hand. And we should see that it's, for getting started. Excellent. So we have now created an image template, but how do we actually make a container from that image? Well, we are now going to follow along with a different tutorial. And I will paste this link in the chat. And we'll go from there. Now, before we proceed, we stopped in class at the Docker Compose section and pushing the image to AWS. So let's check in on our Docker Compose command, the one that was supposed to create those 4 different containers for the Yelb app before we move on. So let's look at our instance. Again, we have one terminal that was just used to push the image, and we have another terminal that was used to run this Docker create stuff. So it looks like everything was successfully completed. So we have our terminal returned to us. Everything says create complete. So how do we see if that actually worked? Well, we can type Docker. Oops. So one other thing is that your terminal will probably have timed out. So after about 5 minutes of us not doing anything, it will have timed out, which is perfectly fine. So we can go to EC2. And let's actually just duplicate this tab. So we have another EC2 tab open. And if we go to our load balancers, so let's scroll down, we should have a load balancer created for our Yelb application. And indeed we do. It says it was created at 8:30, so it finished up about half an hour ago. Now let's look at this DNS name. So again, DNS is a way of connecting to resources over the internet. It stands for domain name system. We're going to copy this link and we're going to paste it into our browser. And lo and behold, we get our Yelb application. So we can, vote for pancakes, vote for Chipotle, vote for Outback, or vote for Buca de Beppo. And we can see that it's, splitting these up. We can see that there's been 1 page view so far. If we refresh it, we have persistence and it loads very quickly. So that's our cache working. And we can see that now we have 2 page views. And if we refresh it, again, we have 3 page views. And I can, keep voting for different choices. And I can keep refreshing. I have 4 page views. I can even copy this, put in a new tab, and it will again persist. Now I have 5 page views. So this is very, very helpful when you're trying to build an application that has, a persistent database and it's very fast to load. And again, we didn't create any of this by hand on AWS. We used Docker Compose to translate from that YAML file and automatically launch and provision resources that we need on AWS. So your third screenshot is taking one here, make sure we can see the DNS endpoint and see that you've interacted with this application. And your fourth screenshot will be going into ECS, so the Elastic Container Service. If it's your first time, you'll probably see this Get Started tutorial. Instead, go to Clusters and notice that you have one created called Docker. So we're going to click into Docker, and we should see that we have 4 running services. We have our UI, our database, our app server, and our Redis server. And those are the exact same services that were specified in that YAML file. Again, all automatically created and provisioned for us by this Docker Compose command. So now that we have those services up and running, we can take a look at the UI, for example. We can see that it has some load balancing. It's got that target group that we used with auto scaling. And we can see it's got one desired task and it's running one desired task. So why do we need load balancing if we only have one running container? Well, let's say we wanted 5 running UI containers so we don't overload the CPU that's allocated to each container. Well, I could increase my desired count. That would then increase the running count. And then I would need a load balancer to automatically balance traffic between each of those 5 containers, or 10 containers, or 20, or 2, or 4, or any number. And so that load balancing is very helpful for ensuring that no single container is overwhelmed. So your fourth and final screenshot for completing the lab is this. I want to see that you are in this Docker cluster and you should have 4 running services: your UI, your database, the app server, and the Redis server. Again, make sure that your account name is fully visible in the right-hand corner. Take a screenshot here. So we now have our 4 screenshots that we covered. I'm just going to, again, take a quick look here. So we took a screenshot showing that we can access our Docker Compose architecture from an application load balancer. And we're going to take a screenshot showing that our application is running as 4 separate services. And again, just my own personal notes here. So our Docker Compose YAML was a really helpful template that translates Docker container architecture into AWS architecture, and it's reusable. And then Docker Compose, again, enables this quick creation of our multi-container architecture. So all we had to do was run that Docker Compose command, and we have 4 containers. It broke it up into separate containers or separate microservices. So if there's a problem with your database, for example, it doesn't require you to tear through your entire app. You can just look at the database, fix that problem, and redeploy the container. And again, on the business side, very, very helpful to split up each of these parts into smaller components. It makes it easier to debug problems. And it's also easier to showcase certain features when you have them running as separate containers. And then, of course, we talked about the depends on field that specifies that other containers must be running for our architecture to work. Can't have a website if our database is broken, for example. And we are now going to use Docker Compose down to actually destroy all of these resources. So again, make sure you have your screenshot showing that you can access Yelp. Make sure that DNS endpoint is visible, and then make sure that we can see you have your 4 services running with that account name. So this concludes the regularly assigned lab. Now that we run the Docker Compose down command, so let's go ahead and check if one of our terminals is still working. It's not. So let's go ahead and close out of one, and let's open up another. So we'll go ahead and hit connect. And then we need to, again, change directory into Yelp. Then we can list the contents. We can change directory into our deployments. Then we can change directory into our platform deployment, and I use tab to autocomplete there. And now if I change directory into Docker, I am back where I was at the beginning. I can again switch my context, so Docker context use, and then my ECS context. And I will now run Docker Compose down. This command will destroy all of the architecture that we created. So run it after you've taken your necessary screenshots. We want to do this because it created a load balancer and security groups and containers, and we don't want to leave any of that running and potentially get charged. So we just hit Docker Compose down. And it will take some time, just like the create command took a good 10 or 15 minutes. Destroying all of that stuff will also take 10 or 15 minutes. So we're just going to kind of leave this running. And then at the very end, we can come back and check that everything was destroyed. If you are interested in the extra credit, and again, this will be up to 10 points extra credit in your lab. feel free to follow along. It will only take about another 10 minutes or so to get the rest of the credit. So let's check in with our kind of instruction manual here. We created our image and pushed it to ECR. And now we just have to work with ECR and ECS to actually create a container from that image. So how do we do that? Again, we're going to use this tutorial here, and I believe I'm going to double check that link is in the chat. So let's see what comes next. So this is another just really good tutorial overview of how everything works. We're going to skip a lot of this. We already created our own Docker file, so we're going to keep skipping this. We built it, we pushed it, we ran it, we've done all of that. We've logged in. And now, how do we actually start using it in AWS? So let's go back to our console and let's take a look. We can also, again, refresh this, and since it times out, we can see that our container architecture is starting to get destroyed. So we can just close out of these tabs as well. So let's go to ECR. So I'm going to switch from ECS to the registry. And again, the registry is where our images are stored. Let's take a look at the image that we created. So we need its URI. The URI just tells AWS where our image is located. So what kind of container am I running? Well, you're going to run the container that has this image. So we're going to copy that. And now we're going to go back to ECS. And we should see this Get Started page. If we don't, you need to go to this link here. So I'm going to copy this link and put it in the chat. And I'm going to, again, go back and get my URI. That stands for, I believe, Uniform Resource Identifier. Again, it's just a basic way of having AWS know what kind of image to launch. So then we are going to go to our clusters. We're going to create a cluster. Oh, excuse me. So we need to, go to our ECS homepage. So let's go to Getting Started. Oops. 1 second here. Let's just go back to the old console, keep it standard for everybody. And let's make sure that we are using that Getting Started tutorial. So I'm going to open that up. So I'm on this Getting Started tutorial page here. Let's do it in my other AWS account. Let's get that repository URI. All right, now we're all on the same page. I have my URI copied, and I'm at this ECS Getting Started tutorial page. So I'm going to hit Get Started. And it's going to kind of give me a diagram of how ECS works. So we have our cluster on the far outside. That's basically what's the overall application that you're running. Then you have the service. Well, what kind of containers do you need? So we have our Yelp cluster, and we had our database, UI, app server, and Redis services. Then we have our task and container definitions. And that's just a fancy way of saying, what do you need your containers to do, and how many of them do you want? So task definition will specify, how much CPU and memory does each container get, and how many containers do you want? And then the container definition is, well, what are you actually running? Are you running, our Getting Started image, which is what we'll deploy? Are you running Python? Are you running Neo4j or something else? So we have, again, our cluster is the overall app. The service is each piece of our app. And then the task and container definitions specify how each piece works. In this case, we're going to go with a custom container. So I don't want to use their sample. I'm going to make my own. So what do I want to call it? Well, this is where we start doing some follow along here. I want to call it Getting Started, because that is the name of our container. Okay, well, which image do you want to use? I want to use the one that I pushed to AWS. Okay, how much memory do you want to give it? These are just some defaults, but generally they specify 512. That's half a gigabyte of memory. That's pretty standard. And then what ports do you need? Well, if we look all the way back to our original tutorial on this getting started container, it says that we need ports 3000 open. So our Node.js app is running on 3000. Therefore, we need our container to have port 3000 also open. So we just say port 3000. Okay. So the container definition is what we want to run, which image, and the memory and CPU needed. This is very similar to Lambda. So Lambda, we specified the memory and CPU, or that was usually created for us by default. And we also said what kind of code do we want to run. In our lab, we used a temperature sensor. So our container, instead of running a temperature sensor, is running our getting started to-do list, and we specified the memory and CPU that it needs. And again, CPU should be pretty familiar. That's the processing power needed to handle our increased traffic. And then the memory is just for storage. Our port mapping, we already talked about. And so we're going to kind of go from there. So we can look at some advanced options. We do not need to change any of these. But if you were really into container stuff, you could have a lot of fun here setting up some really neat applications. So we're just going to stick with the defaults and hit update. And now we're going to look at our task definition. So we want to change its name. So instead of first run, we're going to call it getting, two T's, started task definition. We're going to put it on a VPC. We're going to use the default task execution role. It says this is what authorizes ECS to pull your private image and create logs. So we need that. And it's going to run on what's called Fargate. So Fargate is a way of serverlessly running containers. So you might be wondering, well, hey, we talked about containers in the serverless lecture. Yes, we did. Not all containers, though, have to be serverless. So if we wanted the ability to SSH into our container, just like we've done with our instances dozens of times, we would not want to run it on Fargate. We would have to run it on what's called ECS EC2 instances. They're instances created for running our containers, and it gives us a lot more control over it. Since our application is very basic, we just want to put it on AWS, and we don't need to touch it after that. We don't need to, run any updates or, add files. We just want our application to run. And so that's why we use what's called Fargate. And Fargate allows us to serverlessly run our applications without worrying about, underlying resources. It's just like Lambda. You say, this is the code I want to run, and here's how much memory and CPU I need, and here are the roles and permissions, but I don't want to actually have to worry about the servers. You can't SSH into what's running Lambda, so to speak. So we've now discussed that. Again, the task definition is very similar to a Dockerfile. It specifies some constraints for multiple containers. So all of our containers will have, half a gig of memory and a quarter CPU. And the difference between a container definition is that it applies to just one container, but our task definitions, those apply to multiple. So we want to change the number of tasks to 3 initially and create an application load balancer. So we're going to go ahead and just save this for now. We're going to move on. And here we're going to define our service. So it's already called getting started service. And again, a service just specifies what piece of your application is running. In this case, our application is just one type of container. So there's just one service. Well, how many containers do we want running? In this case, I want to start with 3. And the reason I want to start with 3 is I want to demonstrate some really nice load balancing and auto scaling features that containers have that are very, very similar to what we've seen with EC2 and their auto scaling features. So I don't have to worry about these security groups. We can keep all this as default, but I do want to create an application load balancer. So just like we've done with EC2, we're going to have the same ability to load balance. So, split that traffic up across our containers. So which listening port 3000 is just fine. We don't need to worry about health check paths. That's all going to be default. And we're going to hit save. So now, instead of just launching one container, I'm going to be launching 3 containers with a load balancer. All right. And again, we've got our security groups will be created. That's going to allow access to our, ELB endpoint. So it handles all of the security group backend stuff for us. And so now, again, it's just going to hit next. And instead of our cluster name being default, we're going to call it our getting started cluster. It's going to automatically create the VPC needed and the subnets. We don't have to worry about any of that stuff. We're going to hit next. It's going to give us a rundown. Again, we've got our task definition. We're going to give it, 512 megabytes of memory. We're going to use our private image that we pushed. It's all going to run on port 3000. And it's going to, create those clusters for us. So let's go ahead and hit create. And it will basically say, hey, this is all the stuff that we're creating. So now we wait for a bit. While we're waiting, let's just confirm that our Docker Compose down command finished. It seems like it has successfully deleted all of our resources. So we can verify that by going back to ECS. So if we open up a new tab, we can, in this case, I've got to log back in because I'm on incognito. So if I go to Elastic Container Service, I can see that I no longer have that original Docker cluster. So it deleted everything there. If I search for load balancers, and then I go down to here, this EC2 feature, I can see that I no longer have the load balancer for my original container. Original application. I now have a new load balancer that is, in the provisioning state. This is for the getting started image that we just pushed and started making containers of. So we can just wait this out. So it's almost done. So as soon as it's done, we're going to take a screenshot here. So let's just keep waiting a little bit for it to finish spinning up those containers and getting all the load balancing set up and ready to go. And again, while we're waiting, we can take a look at some other things. If we recall back, we used Docker Compose again to create AWS resources from a Docker Compose file. So let's check if we have a live terminal, and we do. If not, again, go to connect, and then go through the EC2 instance connect, change your directories necessary to get back to Yelp Docker. And we can see Docker Compose Convert. So I'm going to paste this command in the chat here for those following along for the extra credit. And what Docker Compose Convert does is it changes all of our resources into a repeatable template. So what service does this sound like? Give everybody a few seconds to think about it. It sounds a lot like CloudFormation, and it actually is. So when we used Docker Compose Up to create our AWS architecture, in the same process, we created an entire template that we could use to replicate that architecture across AWS environments. So what do we have? We've got our cluster. It's going to be called Docker. It's got all these different properties. We've got a load balancer that were created. It's internet facing. It's got security groups made. It's got logs for it as well. And then we start creating each of these different services. So we've got a Redis service, and it's got some properties. If we keep scrolling, we have our app service, and it also has some properties around DNS information. We have our cluster, our individual containers. So it's got 256 vCPUs, so it's a quarter CPU. We have the same with our app servers, the subnets it needs, DNS stuff again, our dependencies. This is all a CloudFormation template. And again, CloudFormation allows you to have basically infrastructure as code. So kind of harking back to the business side, if you have a failover of your entire application or even major parts of it, if you have a CloudFormation template, you can feed that into AWS and it will replicate all of those resources again. So it's fantastic for high availability or failover situations, and it automates deployment. So it's a very, very useful feature. to have as a backup. So EC2 should now be just about done getting all of our resources. And indeed it is. Everything has checked the box. We're complete. So now we can go to View Service. And taking a look at our screenshots here, we want to take a screenshot after showing 3 running tasks on the service page. So if we go to Tasks, we can see we have 3 running tasks. So these are all the exact same container. We just have 3 of them, just like we had our EC2 instances. They were all provisioned as the same web server. We just have 3 of them now. So again, for your extra credit, take a screenshot here to show that you have those tasks running. And again, make sure that your account name is visible. So how do we actually access our tasks? Well, we want to click on the cluster name, then click the task ID, then paste in the public IP. So let's start with this first task, 4B0. I'm going to click it. I'm going to select its public IP. I'm going to paste it into my browser, and I'm going to specify port 3000. Again, that is the container, or that is the port that our application is listening on. So I have my to-do list, new item. I'm going to call this Graham Shuckman 1. If you're following along for the extra credit, please type in your first name and last name followed by the number 1. And you can type in anything else you want. So I could have, finish recording lab, for example. And I could, keep adding or deleting as necessary. I'm just going to keep it as Graham Shuckman 1. Okay. And then I'm going to do the same with the second running container. All right. So now I'm going to go back to my ECS page here. Going to go back to my Getting Started service. I'm going to select my second task, D87. I'm going to select its public IP. I'm going to specify port 3000. And notice that it doesn't have any items. So our containers are completely independent from one another. So we may have 3 running, but those are all 3 completely separate containers. And this is very helpful for load balancing if you don't want what somebody's doing in their session to interfere with another user. So again, harking back to the business side, if you have dozens of users, you want to split them up across different containers. Maybe you want those containers to be independent so that the information saved in one isn't getting confused with the information in another. Alternatively, you could have 12 separate website servers, and each one of them connect to one database. That's certainly an architecture we could do. But for our purposes, our containers are fully independent. So to demonstrate that, I'll type Graham Shuckman number 2 and add that item. And then if you can guess, I'm going to do it with the third container. So I'm now going to go back to my Getting Started service. I'm going to select my third task. I'm going to copy the public IP. I'm going to paste it and select port 3000. And now I'm going to type Graham Shuckman number 3 and add that item. Okay, so I have now gone into the specific IP addresses of each of my containers and put in 1 item each. But as we know with load balancing, the whole purpose of load balancing is I have 1 endpoint, which ideally I would then map to a Route 53 domain and call it something like grahamshuckmancontainers.com. And from there, it would automatically route me evenly to each of my containers. So why did we do this? We want to first make sure that we get routed to a different container each time, which is why we tagged it with 1, 2, and 3. Now, again, by default, there's no way to access our containers on Fargate. So that's why it's a serverless approach, and that makes it far cheaper. It's not running on an instance, or at least not one that we can interact with, so it's very, very cheap. Now, we could have launched our containers on EC2 instances and SSH'd into those if we wanted to run some updates on our containers. But this is not a serverless approach because it's running on EC2, and it's also a lot more expensive. And it kind of defeats the point for our purposes of showing how to run applications without needing any servers. So now let's actually connect using our load balancer. So we want to go to our load balancer, and it should be, if we refresh, in the active state. So that means it's all working just fine. And now we can scroll down and select its DNS name. So that's the basically website address we need, and paste that into our browser. So it's going to think about it for a few seconds and then realize that it's trying to connect over port 80. So that's not going to work because our containers are running on port 3000. So if we type 3000, it will then immediately connect. And it looks like I'm on Graham Shuckman number 2. So for your screenshots for the extra credit, I want you to take 3 screenshots, each showing a separate container connection from the DNS address. So first we connected to the individual IPs just to make sure that our containers look different. Now we want to use our DNS address and take a screenshot every time we hit a different container. This may require a lot of refreshing, so I keep hitting number 2. Well, now I've got container 1. So you would take a screenshot here showing it's a different container. And now I hit number 3. So those are the 3 screenshots you need. Again, make sure it's with the DNS address specifically. Okay. So using the ALB, again, far superior to individually connecting to the IPs because it will balance the traffic across those 3 containers. So if I had millions of users visiting my containers, I don't want all of them to just visit the first. I want it to spread that across all 3 of those containers. And in the case of millions of users, I'd probably need a lot more than just 3. So now we're going to actually demonstrate some quick auto-scaling features. So and we're actually just about done with the extra credit part in case you're wondering how long this is going to go. So now what? Let's go ahead and edit the service, and we're going to explain how this is similar to auto-scaling, and we're going to drop the desired number of tasks to 2. So remember, at launch, I said I wanted 3 tasks. I want 3 running containers of the same image. So these are all part of our item kind of application. And now I'm going to drop it from 3 to 2. So maybe I expect that demand is going to reduce, or I have some cost concerns and I need to drop my resources. So to do that, I'm going to go back to ECS, and I'm going to go to update cluster. So sorry, not update cluster. I am going to edit my service. So how do I do that? I'm going to select the service, and I'm going to hit update. So what do I want to do here? Instead of 3 tasks, I only want 2 tasks. So that will delete one of my containers. So yeah, we're going to drop it to 2. I'm going to hit next step. Health check. This is all very, very similar to ELBs. I don't want any health check periods. I want this to be instantaneous. And then it's going to say, hey, you're still using the load balancer. I'm going to go to the next step. Here's where I could set up the actual auto scaling in response to CloudWatch. So we did that with CPU utilization. Since I can't SSH to force that CPU to max out, I'm not going to set up this kind of auto scaling. But if I wanted to, I could hit configure, and I could have a very similar layout: the minimum, the desired, the maximum, the roles, and the scaling policies, all identical to what we've done with our EC2 instances. So again, from a business standpoint, this is where containers are super powerful for easily being highly available and elastic. They will respond to increased demand. And again, we're not running any of this on our own instances. This is all running on Fargate, so totally serverless. We can't SSH in, but it is significantly cheaper for us to run. Next step. Just again, confirming I want 2 tasks. I don't need to worry about any of this network stuff, and I'm just going to not worry about auto scaling. I'm going to hit update service. So again, let's take a look at what's happening. So if we view our service and we click our tasks, we can see that we still have 3 running. So let's look at our events, see if there's been any updates. And we can see that it said, hey, I want to deregister a target because I want to only have 2 running containers. So 2 are my desired instead of 3. So I'm going to start getting rid of one of those. So I deregistered it from the target group. That's what's used for load balancing. And I'm going to start connection draining. So what is connection draining and why is Fargate doing this? Connection draining says I'm going to kind of keep this connection alive on the resource for a few minutes after I've actually declared it to be terminated. Why do we do this? Well, let's say you were scheduling your COVID vaccine, but you were in off-demand hours. So the server that you were running in, or server that you had connected to actually schedule your appointment, was scheduled for termination. You know, it's the end of the day, people aren't scheduling as many appointments. Well, you don't want to suddenly get kicked out halfway through finishing up your COVID registration. So it's going to give you 5 minutes to basically finish up whatever you were doing on that website or on that resource, and then it's going to actually terminate it. And that's called connection draining. So it's going to give users a chance to finish up whatever they're doing on the application before actually terminating that connection and the resource. So again, very, very useful from a business perspective. When we schedule things for termination, we don't want to suddenly just remove it because that could have a negative impact on our users. We want to have that little bit of grace period where we're not accepting new connections. We're just giving people a chance to finish up with whatever they were previously doing. All right. So that will take about 5 minutes because that's something set on the load balancing side. So we're just going to wait that out. And then we're going to take a screenshot here that shows that our target has been deregistered and the connection is being drained. So take a screenshot here, make sure we can see these 2 lines. So one's saying that the target's been deregistered and the other that the connection is being drained. And again, make sure that your account name is visible. So this again will take about 5 minutes or so to finish draining. So we don't need to wait that amount of time. We can just start deleting our cluster completely. So last, what are we going to do? We're going to destroy all of this. I'm just going to make sure that there's nothing else we need to worry about. So we have terminated our resources, or we're about to terminate our resources to avoid being charged. And so to do that, we are going to go to our clusters. We're going to select getting started again. And then we're going to hit delete cluster. So it's going to say, hey, you're going to delete all the CloudFormation stuff. You're going to delete the resources inside of it. So yes, we do want to delete all of that. So we can hit delete me, and it's going to start doing it. It's going to take a few minutes. So again, let this run. You can start closing out of some tabs. I would again recommend just doing a double check on EC2 when this is done running. Make sure it actually has removed the load balancer, though it seems to be doing that right now. You can start closing out of all of these. We can see it's no longer connecting to any of our containers because those are starting to be terminated. And so we have successfully done 3 things. So if you've followed along for the extra credit, congratulations. Just to walk through what we've done, we started by launching a multi-container architecture called Yelb. We used Docker Compose to do that, which automatically also created a CloudFormation template. We then created our own container image to run this getting started app. We pushed it to the Elastic Container Registry. And from there, we used it to launch multiple containers. We used some load balancing to see kind of how that works. And then we also played around with some of the auto scaling features as well. So hopefully this has given you a very good understanding and appreciation of containers. From a business perspective, from a deployment perspective, they are invaluable. They separate up your application, or separate out your applications into independent pieces called microservices. That makes it easier to debug problems. It makes it easier to add new features. It makes it easier to have high availability because you can scale out different parts in response to demand. And it also makes it easier to take advantage of previous work. If I'm trying to deploy a Python app, I just need a Python image, specify some of the libraries I'm using, and a couple of commands I need my container to run on startup, and I can push that to AWS and have it running in just a few minutes. So really the container system is invaluable. And I hope all of you kind of have a better appreciation for it. And now we can see that our cluster has been deleted successfully. If we go to clusters, we can see we don't have any. And last but not least, we're going to go ahead and get rid of our repository here. We don't need it anymore. So we're going ahead and hit delete, type delete. We can see we don't have anything in ECR now. So we can double check that. We have no repositories anymore. Nothing in ECS. We can check on EC2, see if we have any load balancers. We don't. Another nice thing is because we've used Docker Compose up and down and we gave ECS time to delete stuff, we don't have any excess security groups. So everything that was created has been destroyed. So we don't have any lingering resources. And now we can finish creating or terminating our instance. We don't need it anymore. So we can start closing out of all these tabs. And we can actually go ahead and terminate. Just going to do one last check. We did all of this. We had already taken the screenshot before. We already looked at the access from the load balancer. We already showed the application running. So we are good to go. So last but not least, we're going to select our instance. We're going to select terminate and terminate. So again, thank you all for following along. I hope you all learned something, and let me know if any of you have any questions at all about this lab. Be sure to use EC2. Follow along very, very carefully as best as you can. And I will let you know when this recording is ready. See y'all.